So section 6, section 5, chapter 6, section 5. And this is the last section of the chapter. What we're going to look at here is how studies are used to collect data. And what's important now, we've talked about bias and sampling. Now we're going to talk about bias and questions. What is an experiment? What is an observational study? What's a controlled experiment? What is a control group? What is a treatment group? And what is a randomized comparative experiment? So we're going to go ahead and go through this section and talk about these things. This section is actually going to be a lot of discussion and not a lot of calculation. So that might be good for you, might bother you, I don't know. In designing a study, it's important to survey your questions to see if they're biased. So one problem with creating a survey or with doing an interview in which you have questions is that the way in which you ask the question can introduce bias. It can reveal a viewpoint of the person who's conducting the study. It can be leading. So what you don't want is you don't want wordings that encourages or pressure the respondent to answer in a particular way. You don't want questions that are going to be too sensitive to answer truthfully. So you've got to be careful about what you're asking. And the question may not provide the respondent with enough information to give an accurate opinion. So you need to make sure that it's clear about what it is asking, that it isn't going to try to push them in one direction or another, and you want to make sure that it's a reasonable question to be asking. So if you take a look at these questions from a survey, we're going to talk about how these could be worded better. So for instance, they're asking parents, do you agree with the school board's proposal for new technology in our schools? And the problem with this is he's asking if you agree. So it's almost as if the question is taking a stance that you ought to agree. And as such, you'd look at this as being a leading kind of a question, okay, which is a problem. So what might be better would be to put in something like, how do you feel about the school board's proposal? For new technology in our schools. I'm not going to type all that out, but you get the idea. So this is better because now I'm not leading them in a direction and suggesting that they should agree. Okay, I'm just asking them blankly, how do you feel? That doesn't lead them in one direction or another. Similarly, over here, if a dentist is asking patients, do you brush your teeth at least twice a day and floss every other day? Well, this is introducing the bias of the dentist. This is what he thinks you should do, so you're being pushed to answer in a certain way. So better would be to say, how often do you brush your teeth? And how often do you floss? These are much better questions than the questions that are in the problem. Okay, so what you want to make sure is that your bias isn't evident within the question. So go ahead and take a look at some problems. Do problems 3 through 6. Then come back and we'll talk about experiments and things. So when you talk about experiments and observational studies, so we've talked about surveys. So surveys are one method. And now we're talking about actually doing more in-depth research than a survey. So surveys are one way to collect data, but sometimes surveys are insufficient. Yeah, I can't do a survey to try to find out if a particular drug is working for curing a disease, right? So if I'm doing medical research, a survey really wouldn't be helpful. I'd probably want to work on an experiment or an observational study. So as the book is saying here, for example, many studies are designed to try to determine whether a quantity that varies can be associated with measured differences between two different groups of individuals. So in a medical study, if I give one group a medicine that we think will have a certain effect, and another group gets a placebo, which is they think they're taking a medicine but they're not taking anything at all, then does their condition improve? That would be an experiment. Okay, so in an experiment, it imposes a treatment on individuals in order to collect data on their response to the treatment. So this could be a medical treatment. It could be, adding methanol to gasoline to see if it improves fuel efficiency. So anything where I have a hypothesis, I think this will help. I create a study where we actually test it in action. This is a type of an experiment. And in some cases, it's difficult to control or isolate the variable being studied, or it may be unethical to subject people to certain treatment or withhold it from them. So for instance, if I think something might cause cancer, it would be irresponsible to conduct an experiment to see if it causes cancer. I wouldn't want to give people cancer in order to determine that that was a cause. So what an observational study does is it observes individuals and measures the variables without controlling them or introducing things to them. So it basically observes what they're doing in their natural state, what they're choosing to do. Whereas in an experiment, you actually impose something onto the environment you're studying. So that's the key difference is, in this case, the researcher is taking an active role in changing the environment, whereas in this situation, the researcher is observing the environment. Okay, so they're not changing it inherently in order to see what happens. Okay, so when you take a look at this, you want to see, well, which is this? Is this an experiment or an observational study? So in this case, a researcher asks college students how many hours of sleep they get on an average night and examines whether the hours of sleep affects students' grades. Okay, so in this case, is the researcher changing anything? No, he's asking them questions and he's making a comparison between what they say about their hours of sleep and their grades. This is an observational study. It would be an experiment if he purposefully deprived them of sleep and then measured the results. Okay, but in this case, he's just asking what is or observing what is and then making comparisons. A parks department employee wants to know if latex paint is more durable than non-latex paint. She has 50 park benches painted with latex paint and has 50 park benches painted with non-latex paint. Okay, the researcher is doing something. She's painted different benches with different types of paint. This is an experiment. Okay, and when you think about it, this is fine. Nobody's going to get hurt if you paint 50 park benches with latex and 50 park benches with non-latex paint, and you wait to see what happens. In this case, if I did an experiment here and I took a group of students and I deliberately deprived some of those students of sleep to see if it affected their grades, that's not good for them. That could lead to health problems, that could hurt them, that could lead to a very bad semester where their grades drop. It would be inappropriate for me to do an experiment for that. Okay, so go ahead and practice identifying these things. Do problems 7 through 9. Sorry, and again, I've misidentified this. We're in 6.5, not in 8.2. So ignore that. Okay? Come on back to the lesson when you're done. So now we're going to talk about specific types of experiments, so controlled experiments. Okay, and this is sort of the gold standard of medical research is a controlled experiment. So in a controlled experiment, two groups are studied under identical conditions with the exception of one variable. As long as my groups are appropriately chosen and my experiment is conducted appropriately, then I should be able to determine whether or not that one variable is the cause of whatever change we see between the two groups. Okay, so a group under ordinary circumstances is called a control group. That means nothing's changed for them. In the case of testing a medicine, if I was giving the treatment group a medicine, I would probably give the control group a placebo so they at least thought they were getting a medicine. Okay, that way, because what we don't want is we don't want their mental state and the feeling they aren't getting treatment to change. That inherently would make them different than the treatment group, and we don't want them to be different. Okay, the group that gets the treatment is called the treatment group. All right, so this is a controlled experiment, and the key thing here is you have a control group. A group that is being kept in the exact same condition as the treatment group, except they don't get the one variable. Right? In a randomized comparative experiment, individuals are randomly assigned to the control group or the treatment group. Right? And this is the way we would want to do it. You wouldn't want to have them self-select. You wouldn't want to choose them for any particular reason. This is important that it be randomized so that you minimize any kind of bias within the study. So the comparison of the control group and the treatment group then makes it possible to determine the effects of a treatment. And this is when you can actually say, okay, we've done this study, we've observed that this is the result of, let's say, for instance, a medicine. One group gets a placebo, another group gets a medicine, and the group who gets the medicine has improvement. Now, it might not be a totally random group because you may want everybody to have a specific medical condition. So you may want to take a look at, say, people with high blood pressure. You don't want people who have normal blood pressure necessarily in that group. So if you take maybe 100 people who have high blood pressure, you randomly assign them to a control group or a treatment group. You give the control group a placebo pill, so basically it's a pill that doesn't have any medicine in it. And you give the treatment group the medicine you're testing. If the treatment group has a reduction in blood pressure, then you can say, oh, hey, our drug works. And then maybe conduct further studies, go to the FDA. Obviously, the FDA requires a lot of testing, but this is a really simplified version of explaining what happens. Okay, if you want to evaluate a published report, you want to take this information that we're talking about and look at it and see, is this going to be a valid report or is it going to be a piece of junk? Because anybody can conduct an experiment and then say they've determined results, but if it's a flawed study, then you should have the background to understand, oh, this study was flawed. I'm not going to believe that, because it's very popular for people in marketing to publish the results of a supposed study that was conducted poorly or was conducted with bias, so that they predetermined what the study was going to determine. So you want to make sure that you're educated enough to not be fooled by that type of study. Okay, so what we want to do is we want to analyze this and take a look at this and determine whether or not this study is a randomized comparative experiment. So let's take a look at this. At Ashland Middle School, students were given the choice of drinking milk or other beverages at lunch. 50 students who chose milk were monitored for 1 year, as were 50 students who chose other beverages. At the end of the year, students in the milk group had 15% fewer cavities than students in the other group. Is this a randomized comparative experiment? No, absolutely not. And the key is the students were given the choice. This was a self-selected group. This is not randomly selected, it is self-selected. Well, guess what? The students, let's say, I don't know what the other beverages are, but if you see students who habitually drink milk, and that's their choice, when presented with milk and soda and other things, they choose milk, then they have a habit of doing something, and it makes it a bias within the study. And the students who reject the milk also have biases. They may be more prone not just to beverages, but to consuming other types of sugar, sugary cereals, more candy, more, it can say a lot about what their habits are in terms of eating in general. So it's not appropriate then to say this is a randomized study. It's not, because the students self-selected into the group. Okay, so what is a well-designed study? If you're going to take information and believe it, you should be able to identify it being a well-defined study. So a sample survey, you would want a random sample to be selected. That would be the best from the population studied. For an observational study, as possible, you want them to be random, but you want random samples from the group being studied. Right? Unless you're studying something like positive deviance, which is the study of why someone from a particular group excels. Right? Then there's no point in doing a random study. You want to specifically look at the people who excel. Now, once you've identified people who excel, you might then randomly select them. So maybe you've identified 100 of them, but you're going to examine 10. So you randomly select the 10. In an experiment, students are assigned at random to a treatment group or a control group. So we're talking about surveys, observational studies, and experiments, and what makes a well-designed study. Okay, an observational study can identify correlation between variables, but not causality. So that's important in the kind. Let's talk about what that means. Not causality. So it can show potentially that two different variables have a relation. That's a correlation. So, for instance, sleep and grades. You may find that students who get 8 or more hours of sleep have higher grades, that there's a correlation between sleep and grades. But what you can't say is you can't say that more sleep causes better grades. All right, so that's what they mean by correlation. It shows correlation, but not cause. Okay, because there are other variables that might affect things. Okay, so there's more example here about vigorous exercise may correlate with longer life, but comparing groups only on exercise and not other issues like, genetics or diet or things like that, it's not thorough enough to make that determination of cause. A rigorous randomized comparative experiment eliminates other sources of variation. That's really important. That's why you have two groups that are identical except for one thing. It eliminates the other sources of variable, and it can make valid cause and effect. So it can be used to establish causality. All right, so it's important for you to determine that. An observational study is not going to determine cause, but a really well put together randomized comparative experiment can determine cause. That's important. Okay, so if you take a look at this particular study, now we're talking about selecting the appropriate study for method for what you're looking at. So would this following research topic be best investigated through an experiment or through an observational study? And explain how would you design the experiment or the observational study? I want to know if listening to music using headphones for more than an hour per day affects a person's hearing. Okay, the real important thing here is that it might affect a person's hearing. So I'm not going to conduct an experiment. All right, I'm not going to do something where I might damage a person's hearing. That would not be ethical. Okay, so we are going to go with an observational study. Okay, so what I would want to do is I would want to identify a group of people who use earphones for more than an hour a day, and another group of people who don't use earphones more than an hour a day, randomly select a smaller sample from that group perhaps, observe them over time, and do hearing tests at the beginning of my study and hearing tests at the end of my study in order to see, was there a change? Was there a greater change in the people who used earphones for more than an hour than there was for people who used it less than an hour? Okay, so you go ahead and practice that. There are no right answers, no specific single right answers to these. There are a lot of different ways you might design this to have it be appropriate and effective. What was most important is knowing it would not be ethical to do an experiment in this case. Okay, so we're done with this section. Do problems 10 and 11, and that wraps up 6.5.